Okay, we are back. Let me know if the video looks a little bit better. I did downscale it, so unfortunately, I wanted last time to make sure that the quality of the stream was higher because we were doing things with graphics, and I noticed on some of my recordings it looks a little blocky because of the scaling. So let me know if that goes better. And in the meantime, let's switch over. Thank you for helping with that. Okay. Okay, so let's talk about fixing up the velocity of the enemies. And please do again let me know if the stream quality is too low. I don't know what I can do about my ISP, but at the very least I can spend less time on my CPU encoding. Okay, so we're going to try to fix up the velocity, and then we're going to do something fun, which is spawn enemies randomly on an interval. And this is kind of how those survivors games work. And then we'll hopefully get to spawning a player and being able to move the player around with the keyboard. And then, yeah, and then we'll make the spawned enemies move toward the player. So if they're spawned randomly around the game space, then we want them to chase the player, which is the part of the point of the game. You have to dodge them, etc. Cool. Thank you, Isaac. The stream seems fine. Good. And then I think we want to. One of the things that was contributing to me being unable to see the ghost character that we spawned moving was that the screen size in proportion to the sprite size is like really big, and so moving it by 1 pixel at a time didn't look like much. So what I want to make sure that we can control the window size to an aspect ratio that we prefer, and maybe even like a physical size that we prefer. And then we'll see about scaling the camera so that the sprites seem bigger and it doesn't seem like this like massive space for them to move around in. So hopefully we'll get to all that. But let's look at the velocity first. So remember last time I think we had 1 and 1 in here, and that's why we couldn't see this. So if I do cargo run, and we spawn it, and you can see now our ghost is moving, right? He's tiny still, but he's moving across the screen. So we are doing that part correctly. I was not crazy. It just seems, and one of the things that's interesting in the tutorial that I shared last time, hopefully some of you got to watch that, or work your way through it even. They tend to set a bunch of like constants up at the top. We may want to do that for this, but for right now, we get a velocity that makes sense. We actually can see it moving, so I think that's pretty much a win for that task. So we're working on enemies. So we want to make sure that we can spawn these enemies randomly on an interval, and we want to pick a random direction. So I've been thinking about this, and I'm wondering if we should make these components, like the velocity component, have two pieces, which is a direction and a speed. Like intrinsically, velocity vectors have that, right, by their magnitude and their direction. But we might be able to do something like, these vec3s have they probably have some functions that can construct them from a particular angle or set of angles and a magnitude. So we might do something like that, and then we'll want to keep maybe we'll start here and say const ghost speed f32 in all cases, and let's say 30, and then we might do something like yeah, so let's start with that, and let's go to velocity. Let's make a new function that is from angle magnitude, something like that. And this is going to be, angle is going to be an F32, and magnitude is going to be an F32. And then we can do vec2 from angle times magnitude, and then we're going to extend that to 0 and return self value is that. Hopefully that's not too confusing. But what we're trying to do here is, have a way to create that such that we can, say, hey, we're spawned way over here, but eventually we want that character to move toward the player. So what we can do is figure out. Now we could also pass a vector. Let's not do from angle. Let's do let's say from direction, and yeah, let's rename that, because what I want to do is be able to take this be a vec2, or even a vec3. Yeah, so we could do we could normalize this. Normalize, which makes it a unit vector, and then multiply by the magnitude, and then we don't need this extend because this is a vec3. Yeah, we don't even really need that. Friends there. Okay. So, or we could, let's even rename this from direction speed. And I want to rename that speed because it is a velocity. Okay, so let's go back to here, and one of the things that is kind of awkward, or is going to continue to be awkward, in that we have a 2D game, but we're using 3-dimensional positions. Yeah, I think that's going to continue to be awkward, but maybe we can, if we're spawning this and using the position of the player eventually, sorry, I'm thinking way ahead of this step, right? But maybe let's just leave this, and then if we need to fix it later, let's fix it later. How's that sound? Okay. So now let's change this and say, we're going to say here from direction and speed, and we want 30 is the speed, but we actually want that to be ghost speed, right? And the direction is, let's just do vec3x. Is that... There's some constants. I don't want to swizzle. Oh, yeah, it's just x. I don't know why it wasn't showing that up first. Okay. And let's look at the warning. Okay, that's just like unused. Let's not worry about that. Okay, so now yeah, okay, so now he's moving slower than we did before, because remember he was going 30-30, which is, quite a bit faster than just 30. So now he's moving along the x-axis at 30. Okay, and then what we'll do later is substitute this with the direction toward the player. Okay, so we want to spawn some ghosts in random positions. So we're going to change this from post startup, and let's create a spawn timer. Spawn timer, and does it have a timer? Yeah. and this is going to derive resource. Okay. And we need debug on that probably. Okay, and so let's look at the documentation for timer. Okay, so it has. We're gonna have to create this in a system. So let's I think we have to do add resource. All right, let's look up the docs real quick. Bevy app. Okay. Is it init resource? Okay, so if we implement default, we can create our resource as we desire. Okay. So let's impl default for spawn timer. Okay. So we want to do this, and we need a way to make a timer. So let's look at the timer struct in here. Not here. Hello. Timer. Okay. So we want it to have a particular duration, right? We probably use from seconds. Like a spawn every second. And then let's look at this timer mode, repeating. Okay, so we want to spawn one every second with repeating. Let's start with that. And what we'll do is, again, so that we're keeping this easier to tweak, let's say spawn interval, and that's, let's say 1 second. And this is going to be spawn interval. And then timer mode repeating. Okay, and then in here we can do init resource spawn timer. Okay, and then this actually doesn't need to be pub because we're only using it in this module, right? What's wrong there? Oh, dot. Okay, so then what we want to do on, rather than doing this post startup, we want to do this on update. And instead of just blatantly doing it, which would update every frame, we would spawn a new ghost. That'd be kind of crazy. But instead, we want to make sure that the timer has expired. So let's see, timer is going to be a resource of spawn timer. And what we're going to do is say if timer Chris, hey, welcome. We're doing some Bevy. I'm so excited you made it. Cool. Okay, so we want this. I'm tempted to implement deref for this, but maybe we'll just go and do timer.0, right? Just say just finished. So if it just finished, then we want to spawn. We want to spawn our ghost. So this will ensure that, you know, our timer is repeating, right? And then we will spawn a new ghost every second. So before we go any farther, let's make sure that this works. So remind me if I don't remember this time to make sure I'm not like getting hasty, because that was the problem we had last time where, oh, this thing isn't moving. Well, it is because it was moving too slow for me to perceive. So Let's just run that. Um, okay, a second hopefully has passed. We're not getting anything. Let's put in some output here. This is what helped me last time. I'm gonna just say spawning ghost. Yeah, can't type. A ghost. And then we can see if this see if this actually is running. Okay. And let's look at our. Okay, so it is not ticking. So I think the init resource might be wrong. Yeah, let's look at init resource, because maybe what we want is insert resource. We want insert resource. Let's try that. Insert resource, and we're gonna do spawn timer default. And let's restart the game. Okay, so it's not. Let's get a little bit more paranoid here. Trying to spawn a ghost. Yeah. And if this doesn't work out, I will look at the sample tutorial, because they do something similar, and we can see if we're just doing it wrong. It's very possible. Okay, so it is calling this system on every frame. Let's cut the time down to, let's do it every 10th of a second, right? And then see if we. Yep. Okay, now this is not helpful anymore. It's just spamming us. Trying to spawn a ghost a lot, and it's never finishing. Let's look at what the other methods on this timer might be. Maybe there's something in there too that I'm missing. Timer. Okay, well, finished is the same as just finished for repeating timers. Are you ticking the timer? Do I have to tick the timer on every? Like I have to oh, tick. Ah, thank you, Chris. I did not know about this. I thought these were automatically maintained. Okay, so what we need to do is update it. So that's good to know. Okay, so I suppose that means we need res mute here. I don't know if that's still a thing. Yep, it's still a thing. Okay, so what we're going to do is we also need the time. And this is the one that we've used before. We used it in velocity, right? So so we need to tick the timer by that. Thank you for that call out. Okay, so we're going to say timer.0.tick. And then we're going to say time.delta seconds, or delta, right? Okay, so yeah, we didn't have before. We didn't have a way. Right, so this needs to be mute timer. We didn't have a way to tell it that timer had gone. Okay, so thank you for that call, Chris. That's really helpful. Um, all right, let's run it and see. We got lots of ghosts. Look at them go. uh Fun. Okay, let's set this spawn interval to something more useful, like every half second. Yay. Yeah. Okay, and now they're forming a conga line. Cool. Um, instead of we've got it spawning on an interval. That's a good first step. Um, and now we need to make them spawn randomly in random locations. So maybe let's make let's say like max spawn distance, right? And this will be in the screen or in the board dimensions. Let's maybe say like 500 units away. Meters, let's say, because that's what people tend to say in this. 500 meters away. Okay, so we're gonna have to add the rand crate, unless Bevy has some rand in there, which I don't remember. Let's see, rand built in. Random state. Hash it now. That's not what I want. Okay. So we're gonna use rand here, and let's. What we want to do is the sprite bundle has the transform in it. So we're going to put the spawn position into this sprite bundle, right? So it has transform. So what we want is to make a transform. Transform from XYZ. Right. So we're going to do. Let's say X is rand thread RNG. I guess we're going to need to make the RNG here. Mute. If you haven't used the rand crate yet, pseudo random number generation is always stateful, even if your API doesn't make it look like that. So what they call out here is this rand thread RNG is stored in a thread local variable. And when you grab that, it will either be initialized or reused depending on like whether it's running on the same thread. So then when you generate a new number from this random number generator, it mutates that. It's kind of like an iterator in that sense, but it mutates that. It changes some internal state of the RNG, and then returns you the value. So let's do gen range. And this is going to be max spawn distance to max spawn distance. Okay. And then we'll do the same for Y. We don't know yet whether 500 is going to be too big. We'll find out. And then I think probably what we want to do. So let's go ahead and fix this. This is going to be X, Y, and 0, right? And let's see if we can get them just spawning at random positions. And then I probably want to make it so that we can actually see that they respond. So maybe we will change the direction. Yeah. Okay, maybe make them all run toward the center of the board. Okay, it's got to build a bunch of stuff because it has rand now. I don't know why it's rebuilding Bevy, but maybe that the existence of this crate turned on some things in there. We'll see. Cool. Hmm. Cool. So, for those of you who don't know, maybe I mentioned him last time. Our guest Chris Biscardi, who's currently cooking some food, um, is I used to work with him, um, and he does tutorials about Bevy on his own YouTube channel. So and has a nice I think for pay tutorial series called Rust Adventure. You should subscribe to that if you want to learn more about Rust and possibly Bevy. Great stuff. He's done a block breaker game on his YouTube channel. It's very cool. So I'm learning a lot from Chris. I have in the past. Um, but yeah, check out his stuff too. And one of these days, Chris, we'll actually get you on here as a guest coder or something. So if you're up for it. Okay, so we have our ghosts. They're spawning randomly. They're moving to the right. Pretty cool, huh? Okay. Um, yeah. Anybody remember Idlewild from back in the day? Old Windows screensavers. This feels a little bit like that. Um, let's. Okay, so now let's see. Let's make a direction, which we're going to use in this velocity calculation. And what I want to do is vec3 new x y 0. Let's see, I want it to go from there to the origin, so we're going to do minus vec3 0. So we're trying to make this go from the position it's in toward the 0 point of the coordinate system. So that's, yeah. So the minus would be back towards 0, we hope. So let's give that direction here. Remember that what we did in the velocity constructor here, this from direction speed, was normalize that direction vector. So we're not, it's not going to be faster the farther away it is from the origin because we're normalizing that vector and then multiplying by the speed. Okay, so let's see what happens there. And let's get rid of this info. We know we're spawning ghosts now, which is cool. Let's make them run toward the origin. And they're going the wrong direction. They're going away from the origin. Okay, so I got this backwards. These are the things that, yeah. These are the things that are a little bit fun to deal with. Math. Okay, so now they're like spawning in random spots around this 500 by 500 space, and they're running toward the origin, and they run past it. Okay. So so now let's think about and that is a fun effect where they just kind of overlap. Cool. Okay, so we will eventually add another system here, which will update all the ghosts, probably updating their velocity. At first, we might add acceleration. I think it might be good to have something where it takes some time to turn around or change directions toward the player. That might make more outplay possible, but we'll see when we get there. In the meantime, what we can do is spawn a player and get them to move around, even if they're not interacting with any of the ghosts yet. Okay, so we spawn them randomly. So let's create a new module plugin dance like we did last time. Let's make a new file, player.rs. Import, not import, that's TypeScript. Use Bevy prelude star. And let's add it here. Yeah, that's still in alphabetical order. Okay. So player plugin. And we're going to import plugin again, like we do in every single module. Okay, for now it's not going to do anything. But what we want to do is something similar to this stuff. So let's make a marker component for the player. Debug player. Okay. And let's make a system which spawns the player. Okay. And this is going to take commands again. Commands. And I think that's all it needs. In the... Oh no, we need the sprite assets, right? Because we're going to give this character a sprite. And that's going to be, we need to use create asset loader sprite assets. and we'll go and add a player sprite to there real quick. So let's do that first, and let's go ahead and spawn, make the template of what we're going to spawn here. So we're going to spawn a player, and it's going to have a sprite bundle. Yeah, and I hate that it inserts 4 dots instead of just 2. And then we're going to have a movement bundle. Right. And we need to fill start fields. So let's go ahead and give it a velocity. No, and he's not going to be moving at all. Cool. Except we want that. Okay. And this is, let's do that, and that should fix it. We're not using sprite assets, but that's because we don't have the sprite defined yet. So let's make, let's look at our tiles real quick. Let's see here. Reveal in Finder. Okay, so we've got some characters down here. Let's maybe get this knight character. Let's do the one with the open helmet. That looks good. Tile 97. Okay, so we'll say knight for now in case we want to have different kinds of characters later. And then we'll do this. Asset server.load. And I'm going to copy this and modify. And this is going to be 097, I think. Yep. Okay. Although this like you know, warrior Viking guy looks pretty cool too. Okay. So now we've got the character sprite, our player's sprite. And we're going to do the sprite. Oops, I need to leave that. Texture. Yep, is going to be sprite assets dot knight dot clone. Okay, and now this is not being used. That's what that's complaining about. So let's do app dot add system, add systems, and then we're going to do post startup. There's a question in my mind about whether it should be startup or post startup, but I think post startup makes sure that we have our assets loaded first, and that's probably safer. Okay, so let's see if our player guy jumps on the screen, and he does not. And this is because I didn't add the plugin in main. So let's go and play in main and add plugins, player plugin. Okay. Okay, now we've got our guy. He's sitting here in the middle. Yeah. I mean, we are using the built-in Bevy asset, but you mean like the is a separate crate Bevy asset loader, Chris? If you're concerned about asset loading order. Okay. Um, yeah. So we're being swarmed. Yeah, it's a separate crate. Okay. And but they're going past. They're going through. So we want to go into updating the player's velocity, right? So let's create a new system. Update play, or let's just call it player movement. And this is going to be, there's going to be a query, right? So we're going to have a query of the mute velocity. And we want that for only the player, right? So this second type parameter on query says only select entities that have this component or this set of components on it. So we don't have to be worried about, am I accidentally selecting a ghost here? Hi, the Raji. I'm assuming that's similar to Be Cool. Anyway, so we want to be able to update the velocity of the character, but we only care about the character. We don't need to modify the velocity of the ghosts yet. We'll do that in a separate system in the ghosts. So in that module. Okay, but what we need here also is we need some way to look at the input. So I'm not using any like special input manager yet. We'll probably just use the keyboard stuff here. Key code, I think it is. Yeah, so let's look at this keyboard module. And I think that, so this is probably a system that is added by the default plugins, I'm guessing. Okay. Yeah, so there's an input key code resource. Okay. So if I recall correctly, and we may need to look at the other one, but what we want is a resource of input key code. Okay. And what I want to do here is I want you to be able to press the multiple directions at once. So like you could, we could make it move in like the 4 directions independently first. Maybe we'll do that. But what I would really prefer us to do is have the ability to get you to be able to go on diagonals. So 8 different directions instead of 4. But let's start with 4. And let's do, probably it's just an if else, etc. Right. Let's look back at what this input struct is, what that type is. Okay. Okay, so okay, we want to know if something is pressed. I don't know that you can match on this because all the fields are private. Let's see. Okay, so we can say get pressed, right? That actually might be a good way. And this returns an iterator probably over the contain type, right? Let's do that. And it's not giving me any more details about that. One thing I dislike about the Bevy docs, they're missing some things. Okay, so let's do think about this. Okay, we're going to for key in input.getPressed, right? And we don't care if it's been pressed or like it was just pressed. We don't care about that. And then we're going to match on key because this is a key code. And we can say, so if it's W, right, maybe we'll support up arrow. And let's construct a direction vector 0. So if it's up, we want to do direction plus equals vec3 x. No, not x, y. So y vertical, x horizontal. Okay, and then if we have key code, no, not that we want, probably put brackets around that. Okay, so if we have W or up, we want to add the direction upward. If we have A or left, right, we want to x, we want to subtract x. Now this is not probably the most efficient way to do this, but or the one that makes most sense, but we're going to see if we can make it work. Okay, so if we have S or key code down, let's do minus equals y. Copy this real quick. Right, so we're just trying to build up this the key combos here into this be plus equals x. So you could potentially with this, you could potentially have left and right hit at the same time. Oh yeah, thanks, thank you. That's good to know. You could hit left and right at the same time or up and down at the same time and not move at all in either of those directions. So so let's do neg x. Thank you. Let's fix that. And neg y. Okay. And then for anything else, we just do nothing. Okay. So now what we can do is let's get the velocity. And we are going to do query.single mute, right? So this is a panicking version of this query. You know, in our previous ones, we did loop over them, and even if there's only one thing. But in this case, we know there should be only one player. So let's take that velocity, and we're just going to set it. From direction and speed. So we'll use this direction that we just created, and let's pick out what's a default speed for the player and put it in a constant up here just for safety. Player speed. And I want the player to move a little faster than those ghosts, so we'll give them 50 instead of 30. And let's replace that with player speed. Now this is, again, you know, similar to, yeah, fine, mute. Okay, mute query. We gotta put those markers everywhere. Okay, so ideally this would not be changing the player velocity directly. we should be changing the player acceleration. Then you get kind of a ramp up. But we'll do that. We'll do that later, potentially. Okay. And so let's add that system. It's going to be on update. And it's going to be player movement. And we don't need the parameters there. Okay. So maybe this will work. Let's find out. Okay. Make sure we don't panic anything. Do I have it still running? No, I do not. What's the holdup, guys? Let's cargo build first. Yeah, okay. Cargo run. Okay, now it's running. And our player is not on the screen. Okay. He was before. Let's see. So we've got the player plugin in there. Okay, so let's see. Setting player direction to, let's start printing out some stuff. Direction. And because I want to see, make sure that this is running, first of all. And then we might see, maybe we'll look at debugging the current velocity. And then see what's going on. Let's look real quick at the movement, make sure. Yeah, so we only cared about if it had a velocity and transform. Now it could be an issue of we're setting the velocity at a different time and we need to schedule these so that we update the velocity first and then we update the position. Yeah. All right, let's see what's going on. Okay. So we're not going anywhere. I don't see the player. Let's scroll up here. So we were setting some velocities, right? Okay. What's interesting to me is that Okay. Well, we have determined that our key codes, our key codes are changing this value, right? So, and we're getting combinations of them. That's a good sign. It could be that this is not the right way to do it. So maybe what we should do instead of using this, reference replacement thing, maybe we should have a method on velocity that says, I don't know, change direction or something like that. Let's start with that. I think we might be able to change, I don't know, change direction speed. This is going to be really rough. Mute self, direction is vec3, and speed is f32. And then what we'll do is we'll say self.value is vec3, basically what we did here, right? Direction.normalize times speed. Let's do that. At least then I know that, like, We're not having some weird like this thing actually lives over there and we're trying to modify it with a pointer change. So let's say we don't need to do that. We can say change direction speed, and the direction and player speed. Um, I don't know if this is a good way to do it, but I was a little bit worried that that other way was not working. Okay. um, the other thing I want to do potentially here is so we have a lot and transform. I might want to print out the location of the player. The thing is, this query does not include we could include the entity in here and then look up whether the entity has a player on it. For now, let's see if that change we just made did anything interesting. Okay, but we removed all our info prints, so probably not getting any. And what I'm not seeing there is there's something with the existence of this system that we just added. Let's leave that system off and see if we can still see the player, because I want to say that there was something going on there that we didn't, that we messed up, right? Yeah, so now he's here. You can't move him. There's something wrong with our system. Is the player moving off the screen faster than the sprite is loading? No, because update comes after post startup, right? Why don't we, since we are concerned with it in here, why don't we add the transform in here just so we can see it? Right. And then what we'll do is we'll say let velocity transform do this, and then we'll say velocity dot change direction speed. Okay, and then we're going to let's do another info printout. Moving player or player position is going to be transform. That's not going to be that useful, but and direction player, let's just say player movement, and this needs to be mute. Okay, so slow the ticks down while debugging. How would one slow the ticks down while debugging? And I could turn off the ghost spawning for sure. I don't know that there's a way to tell Bevy to go at half speed, if that's what you mean. But we're figuring things out, right? This is new. Okay, so I actually turned off that system still, so it's still showing. Let's turn the system back on. Yeah. Okay. Let's go up here. So, oh, we have a translation of not a number. That could explain why. So, let's put in a default transform in here from XYZ. It is possible though that something in this movement system. So velocity dot value time delta seconds. Yeah, the Batman inner. I think we have the evidence. Okay, so it starts at 0. Okay, let's see what we're doing in this. Okay, so if the velocity is 0 times delta seconds 0, we would just add 0 to it. Should be safe. We shouldn't be dividing by anything. We shouldn't be overflowing anything. And the fact that our ghosts work without modification. Okay, what did we do over here with our velocity? Is the issue here that we can't normalize the direction if it's 0? Yeah, okay. Okay, this is the problem. So we're trying to normalize it. Okay, so let's look at try normalize, right? Or normalizer 0. Let's do normalizer 0. And we'll do that up here too, right? Okay, so this was the problem. Right, so if it can't normalize, it'll return 0, which is fine. Okay, let's see if we can get our guy moving. And okay, so note we can move him sideways, up and down, but I can also press multiple keys at a time. Now I'm pressing up and down, or W and S, and he doesn't go anywhere. A and D, and he doesn't go anywhere. But if I hit S and D, he goes bottom right, and so forth. So, cool. Okay. We can get rid of those prints in the player now. That's an important lesson. Trying to normalize a vector and its 0 length, the answer is not defined. Okay, so we will remove this transform from this query. We don't need it anymore because we're not printing it out. But that was important debugging. Okay, so let's look at our to-do list real quick for this. Okay, so we have spawned a player. We can move the player with the keyboard. So now let's go back to the spawned enemies and make them move toward the player. Cool. Okay, so we just have spawn here. Let's do add systems. And I think what we want to do here is chain these. And doesn't matter. Let's just do for now. We can worry about micro ordering later. Excuse me. Chase player. Okay. Okay, so what we're going to need here is we're going to need the ghosts. And this is going to be a query of we want the velocity, right? And we want the transform because we want their current position. And this is going to be with ghost. Okay, and then we want the player is another query, and we want just the transform because we don't care about where the player is moving with player. So you can see it's honestly kind of nuts how sophisticated the types are in Bevy's ECS. It like blows my mind at times. Okay, so we're gonna use create player, and I hope I made that pub. I did. Good thinking. Okay, so so what we want to do for our first pass, because we're not doing acceleration yet, we may do acceleration in a little bit, but or maybe next time. Let's see how far we get. So what we want to do is make sure that the ghosts are always heading toward the player, right? So we're going to do for velocity transform. Let's do let's do player transform. Yeah. Player.single. Okay. Ghosts. And we want iter mute here. So what we're going to do is for every ghost that's in the game, we want to set its velocity to be pointing toward the player. So we'll get the direction, and this is where our change, and this is going to be mute velocity. This is where our change direction speed is going to be important for this attempt. Okay, so we want so if we were going from the ghost to the player, that's the player minus the ghost. Dot translation minus transform dot translation. Ghosts plural. Okay, and direction is going to be vec3. Okay, so I think this might be backwards based on what we did earlier. Right, we had them move toward the center, and we did 0 minus where they were. Right, so we want the destination minus the current position for consistency there. Okay, so let's do velocity, change direction speed, direction, and the speed is going to be the ghost speed. Okay, so yeah, that's tedious. Okay, I actually kind of wish that this were like a mutable reference or something like that, and then you wouldn't have to put mute everywhere. This is okay though. Okay, so this will make them chase, or it should. The thing that is probably not good gameplay about this is that they're going to change instantaneously. So the only way our player is going to win is that they move faster. We aren't doing any collision yet. We might look into an external crate for that. I'm not sure yet. We might do it like the tutorial does and just say, hey, these things are X by Y size, and if their bounding rectangles overlap, then they have collided. Or if they're, within a tiny fraction of one another, they have collided. But let's get this running and see if the ghost will chase the player. Yep. See how I'm moving around and that ghost is following me? And the only way I'm evading them is I actually move faster. because they are changing their velocity instantaneously. But we got a basic mechanic. Oh, I died, probably. We got a basic mechanic of the game in about 5 lines of code. That's pretty cool. Now, we would probably want to do some things with like avoiding them overlapping, stuff like that. So, interesting. Okay, cool. Yes. All right. Let's look at our to-do list real quick. Run, little knight. Yeah. Okay, so they chase the player now. And maybe this is something Chris could help with, but we talked about earlier in the stream how tiny the character is on this enormous screen. So what I want to do is look at the camera, and we just did the 2D bundle default for the camera. But I think we want to do a combination of maybe modify the window, because I think it's defaulting to nearly full screen. And we'll want to modify something about this camera bundle that'll make it scale up a little bit. Yeah, you can set whatever you need on the camera. True. So maybe let's look at some of those things and figure out what we need to do to make that make sense. Let's look for camera 2D. Camera 2D bundle. So the camera, I don't know that this has what we want in it. Maybe the viewport. Physical position, physical size. There might be some methods to construct it as well. Yeah, that's probably not what we want. We probably want to look at either the projection, the orthographic projection, or the camera 2D. It's just clear color. That doesn't care. That's a little funky. Okay. Let's look at the projection. So, right. Viewport origin. So we could probably do something like looking at, if I recall correctly. Okay, so scales the projection in world units. It defaults to 1, so that's why we're getting these so small. Let's try updating the scale on this projection. And scale it by 2. Okay, so scaling mode, window size 1. I don't know what this scaling mode does yet, so maybe let's just try adjusting this scale. And what has, oops, modded message. What has good info on scaling? Okay, well, let's start with this. We're just going to play with it at first, and we'll say, yeah. Bevy cheat book. Okay. Cool. So let's try projection. And we're going to do default here again because we don't care about that. Let's try scale as 2. And see if we get what we want. Oops, I need a comma down here. Okay. Scaling mode changes how it reacts to viewport size, essentially. Okay, thank you, the Raji. That was useful. We may tweak this a little bit. Okay, so I'm trying to move the character up. I'm not seeing anything. I think this was the wrong thing to change. So let's look at the Bevy cheat book real quick. As suggested. Bevy, oh, hey, I had it in my history. Cool. Okay, so Working with 2D camera setup. Set the transform to position the camera. So we could potentially make it be closer. But let's read this. Okay, so provides bundle. You spawn a camera entity. It has a reasonable defaults to set up everything correctly. You might want to set the transform to position the camera. So we could do XYZ. We probably keep it 0, 0, but then change the Z potentially. But there's also the projection has the near and far, and the near is 0. So maybe that's not exactly what we want. Okay, projection determines how coordinates map to the viewport. 2D cameras always use an orthographic projection. When you spawn a 2D camera bundle this, it adds the orthographic to your entity. When you're working with 2D cameras, you want to access the projection, you should query for the orthographic projection. Okay. Okay, you cannot use this thing. Fine. So the near and far values indicate the minimum and maximum Z that can be rendered relative to the position of the camera. So allowing entities to be displayed on both negative and positive Z coordinates. Okay, so that's what we screwed up there. Is if we set the defaults, we need to set those too. No. So let's go back and let's put our scale back in here. But the defaults for those are both 0. So if we do near negative 1,000 and far 1,000, we should get the view that we had before, but our scale should be bigger. I'm hoping that's what that means. Okay, so we could do that as well. Okay, the default for Bevy is 1 screen pixel corresponds to 1 world unit. And then if Windows resize, that causes more or less content to be seen. Okay, so yeah, we did. I think the Raji mentioned the scaling mode. Yep. That is, we probably don't want to mess with that yet. Okay, so to zoom in 2D, you can change the scale. This allows you to scale everything by some factor regardless of the scaling mode behavior. So zooming in. Okay, so a larger scale is actually a smaller object, I'm guessing. So we probably want to change the scale not to 2.0, but to 0.5. Let's try that out. Okay, so now he's bigger. It looks a little, not great. Partly because these are designed to be tiny. When you scale them up, they're not going to look good. Okay. Well, we learned by this. So I think let's do what they recommend in the docs. 2D bundle default. And then we'll say bundle dot projection dot scale, and let's do 3/4. And then we can say spawn that bundle. This will make it a little bit more clean. Okay. And then maybe what we could do is, yeah, that looks good. I like that 3/4. That looks really good. At least on my screen. I don't know what it looks like on the stream. But that's about a good size. Okay. What we might do then is put this in a constant. There's no code action for that. So scale .75. Let's call it camera scale, and then it'll be at the top of the file. Okay. Okay, so that's still working. Cool. Right. So let's look next at dealing with the window size. See if it's here in the cheat book. Window management. Okay. So coming soon. Window settings. Let's look at the window settings example. Whew, that's bright. Okay. So what we could do is do this set window plugin and change the width and height. I'm guessing this width and height are physical window sizes. Okay. Well, let's play with that. That's actually really easy based on that example. Okay, we'll go to main. Now let's do set window plugin. Yeah. Window descriptor. Doesn't like that so far. Default. And it's possible they haven't updated this for Bevy 0.12, this example. I'm not sure. Let's go to that plugin. Interesting. So primary, it's probably primary window. Okay. Okay. So we need to find this struct. Yeah, you're right, Tharaji. I was just not looking at this, I think, correctly. Position? No. Um, that's doesn't have anything about size unless you're talking about resolution, which I think is more about. Let's look at this struct. Okay, so we're diving a little bit deep here. Okay, so we do want that. Wow. Okay, but see, here's the default of 1280 720. So probably, yeah. So we want window plugin. This is primary window. You know what? Actually, you're right. It's up to date on main. Probably I was looking at the out of date one. Window settings. No, this. Okay, so that was pointing at 9.1. That was the problem. If I look at my main. Okay, so primary window. Okay, so what we want to do, we want to be able to set the title and the resolution. So this is this. That's why I was getting confused. Okay, so let's update that. Cool. Some window default, and it likes to put in. Okay. And my formatting is all messed up here, so it's gonna be hard to see. Okay, so title, resolution, and then we want default. The other thing that we could do is construct this window above. Um, and that is not right. Okay, let's figure this out. Okay, so window plugin, primary window, some window. This is inside here. This is part of this. Some window. Okay, and then default. Okay, and then that's the end of window plugin. And we can remove that, right? That's the end of window plugin. That's the end of set. Remove that. Whew. Okay, let's pick something more reasonable here. Let's do 800 by 600 because I think 1280 by 720 is too big and the other one was too small. Okay, so now we have a reasonable size window. Thank you for the tips in the chat. Okay. And we have about half an hour left. We should make a few adjustments here. In that we were randomly spawning the ghosts anywhere on the screen. We probably want them to spawn at the edges of the screen. Probably within they're probably just outside that, right? And let's change the title real quick. We're gonna call this Bevy Survivors. Okay. So let's go back into our ghost and change how they spawn. Okay, so we want them to spawn probably outside. Outside the screen. So we know the screen is 800 by 600, right? And we were generating this range, the spawn distance, with the default of 500. So that should, on a lot of cases, put them outside the screen. But maybe what we want is for them to spawn at a random location along the edge. So what we need to do is just we need to pick a direction, and then find where that hits the edge of the screen, or maybe a little bit beyond. So let's instead of max spawn distance, let's do -1 to 1, and those are F32s. I need to make sure that that's clear. And this is a -1.0 F32 1.0 F32. Okay, so now we're generating something that is along the unit square, and we want to we know that the X is 800. It's 800 by 600, right? So we can just multiply this by 400, so half of the size of the screen, and the same on this, and then that'll spawn at the edge. I was thinking for a second there that, oh my gosh, I'm gonna have to do some like trigonometry or something, but nope. If we're generating vectors along the unit square, then except this is not necessarily, is it? We may not be along the unit square. Probably what we want to do is say normalize. No, not normalize. Maybe what we do here is, let me think about this again. Okay. We need to be careful about the math here because we could get the Batman problem again, right? The Batman error. Um, okay, so let's just let it generate this range first, and then we're going to um, make it into a unit vector for let's say a spawn spot. I don't know. X, Y, 0. And then we want to normalize our 0, right? So that gives us a unit vector. Vec3 new. That'll give us a unit vector pointing at some spot, some direction we want the thing to spawn in. And then we should be able to multiply that by the dimensions of our screen to scale it, right? Spawn spot. And what we'll do is this will be not from XYZ. This will be from translation. And we give it the spawn spot. Okay, so everybody following what I'm doing here. So I'm trying to generate something on the edge of the screen, and maybe I'll just give it like another 10 units because we want to make sure that we spawn outside the screen. Okay, so we're generating some numbers between -1 and 1. And then we're creating a vector that contains that XY. But we don't want it at that position specifically. We want it on the edge of the screen. So what we want is, let's pick something on the unit square 1 by 1. And now there's a possibility here that this is going to be close to 0. We could also do trinormalize. Because we don't want to return 0. Trinormalize probably returns a result. So let's see about that real quick. Let's see trinormalize. And that returns an option. Okay. So here we can do unwrap and just give it vec3 x. So we can give it a default. That's probably better because normalizer 0, then it will be spawning it at 0 and our scale won't make any sense, and it'll be like, hey, you just popped up randomly in the middle of the screen. Okay. So then we're scaling it to the width of our screen and the height of our screen, so that like stretches out the spawn point to be along the edges. Everybody follow that? Okay. This is a sort of crazy stuff you have to figure out math-wise in your games. And this is a very simple example. Okay. Cool. And now let's give this a whirl, and we should see the ghosts spawning outside the screen and not in the middle of the screen. Yep, they're coming from the edges. Now, there may be a thing here where, because we're scaling, our world space, maybe we didn't need it to be, 410 by 3 something. Oh, I died. Okay. Yeah. because with the camera we scaled it to 3/4. So we're let's put this back at 1. um, and we might see, hopefully they still spawn off the screen. No, but you can see them spawning at the edges, so maybe not. Remember, the coordinates in our ECS are not necessarily the coordinates of the screen. And that's the thing that we're going to have to contend with probably more in the future. But let's put the scale back to 3/4 because I liked how that looked. Cool. Um, yeah, they chase a bit too well. I'm doing okay avoiding them, but yeah. Okay. I think this is a good place to stop for the day. Um, and I made a repository for this. So let's finally make a commit here. Let's rm the zip file. And I think I'm only going to add the ones that we're using in the assets directory. So we don't need to commit all of these files if we're not using them. Cool. Okay, so let's add source. Let's see. Git ignore cargo. Let's add the source directory. And on assets, tiles, we use 97, which was the character. Let's look real quick at our asset loader. Yeah, we use 97 and 121. Okay. Okay. And looking real quickly, this is Creative Commons 0, but yeah, let's just for argument's sake, let's add the license. I don't, obviously the CC0 doesn't require you to, but I feel a little bit better if we have that license in there. Yep. Okay. So let's make a commit. And this is the initial commit. What do? We spawn ghosts randomly on an interval. Spawn the player in the middle of the screen. And ghosts chase the player. Player can move with WASD and arrow keys. Yeah, good stuff. Okay, and I'm going to push that, and you all should be able to check it out on my GitHub page. So I made a repository for it, and it's right there. Maybe we'll add a readme real quick, and then call it a day. I think that it might be good, real quick, to think about what we should do for next time. We probably need to think about like taking damage, so collisions with enemies. So we want to have collision detection. Maybe we'll look at one of the libraries that are in the ecosystem for that. We could write it ourselves based on the tutorial that I showed you from Zymartu Games last time. But we really only care about the at least for now, we really only care about the enemies colliding with the player. And maybe there's like player hit points. And we probably want to do something with like player attacks. So maybe we can figure out how to queue up player attacks and have them damage the enemies. Maybe enemy hit points. Because otherwise, it's just a clock waiting to count down until you're just challenging for a time. I've been thinking about this a lot. At some point, we'll probably want to make levels with different configurations of enemies, and we can start to maybe move some of the some of those things that are specific to the kind of enemy, like what texture do you use for the character, what size they are, how many hit points do they have any special abilities, those sorts of things that start to move to data files and out of code. But we won't do that right now. I would also maybe this doesn't have to happen next time, but let's look at let's generate a background scene. So we're gonna have to load tiles from our assets, and we're going to have to either generate or use some kind of static pattern of the tiles, map patterns into the let's just call it map patterns. Generative might be really cool. We could look at the properties of the individual tiles and find, like, let's generate some edges or something, and then pick the tiles for the particular edges. There's lots of interesting stuff in the procedural generation space on that. It doesn't actually matter what's in there unless we want to have obstacles. Maybe that could be a stretch for next time. Obstacles. So things that you can't run into. We'll need collisions, right? In order to be able to collision detection, in order to be able to have obstacles. And maybe a subtask of this is like enemies push each other out of the way, away from, so that I'm gonna just say enemies don't overlap. Yeah, cool. So I mean, this is the thing I love about this, Bevy, as a way of thinking about things, is you can see in our code there's not much there yet. There's really not. But in the thing with velocity, we're only carrying, like, our system is like 3 lines in the body, and it's just, hey, take the velocity and update the translation of this particular thing. And this is generic over any kind of thing that you have in your application that has velocity and transform. Like this is the this is the cool power of the ECS. And if you're careful with how you structure what components you put on your entities, then you can narrow that behavior to specific things, like we saw in here, where we're like, hey, let's get the velocity and transform of only the ghosts and the transform of the player, so that we can make sure that the behavior is they're always moving toward the player. This is really what I think is cool about Bevy, that we didn't have to have a bunch of global state that we manage. Bevy manages that. It's like a database. We've got queries. They're declarative, and then we make the updates that we want based on those declarative queries. Anyway, I feel like I'm rambling. Thank you so much for coming, Chris. I was super hyped to see you. The Raji, thank you for joining the stream for the first time, and helping out with some of those questions. And we'll do some more next time. Now, a quick note of logistics. I am, given that next Sunday is Christmas Eve, and I'm going to be spending that time with my family, will not be a stream next Sunday. However, I'm off the entire week from December 24th to January 1st. So we'll do some weekday streams during then, maybe more than one if I feel up to it, and we'll just have some more fun with Bevy. This has been a big learning experience for me. Um, and it's also, I don't know about you, but I feel like it's exciting. Like, oh, this is within reach for me. Whereas if I were going with something a bit less polished, a bit more hands-on, I might not be as far along. So that's really cool. And Chris, like I mentioned before, you're always welcome to co-stream with me or jump on and on Discord and be my guest on this, and we'll connect with Zed collaboration if you want. Anyway, thank you all for coming, and we'll see you next time.